Okay, so this last video will not, I don't think, be relevant directly to problems in Pearson, but it will be to an extra credit question, which I will definitely put on the second exam. The extra credit question comes down to, in a sense, proving the quadratic formula or deriving the quadratic formula. Now, what I've written out here is there's a connection between the quadratic equation in its general form, which uses a, b, and c, where it's all equal to 0. There's a connection between that and the solution for x, the quadratic formula. And it's crucial both ways. If the quadratic formula is true, then so is the quadratic equation. If the quadratic equation is true, then so is the quadratic formula. Now, this textbook, what it does, and this is very common, is to start with the quadratic equation and complete the square. Go through the process of completing the square, which makes sense because that's what you study in this section, is completing the square. Now, the problem or the challenge with that is it gets pretty darn complicated in terms of the algebra. So that, it's kind of like, well, you're going to start and complete the square. Observe that you'd have to divide both sides by a, because the a is not necessarily 1 in this situation. And it just gets, the fractions get pretty darn complicated. That's one issue. So there's a simpler way to go about this. And I'll show you what I mean. And here it is in its full glory, right here. So here's the idea. Normally, the way the quadratic formula is proved is you start with the quadratic equation, work your way to deriving the quadratic formula. What I'm suggesting is do it in reverse. Do it in reverse. The order doesn't really matter. It doesn't matter because the idea is each one of these equations follows whether you're coming down the page or up the page. And it's going to be a lot easier to start with the quadratic formula and go down to get to the quadratic equation. Much easier. Well, let's try to go through this and see why, or what's going on here and why this might be the easier way. If you start out with a quadratic equation, so it's, there we are. Multiply both sides by 2a, and that's where you get the second line. Bring the negative b over to the left side, and then square both sides. Now, I think this is more intuitive than the other way, which I'll show you or try to indicate why this will be a lot easier. Square both sides, which I've done writing this in green. You'll have to be careful about here on the left side. I just wrote out what that's going to come down to. You might have to write this out to make sure. And that's fine. You should practice this to get the full extra credit that you'd want. On the right side, the yucky square root stuff just disappears because we're squaring. Hello. So that's wonderful. And notice that b squared, positive b squared, exists on both sides. They cancel out. You could subtract b squared from both sides. And then basically set what's left over equal to 0. Get all the terms that get the terms on the right side over the left side, basically. So you now have all these terms equaling 0. And then using now a familiar factoring principle, the greatest common factor, you pull out or factor out 4a. And then divide both sides by 4a. And there we are. The final step in this proof is what's called the quadratic equation. A times x squared plus bx plus c equals 0. And, well, what if you'd done it in the other order? That is, what if we had started with the quadratic equation and worked our way up to the quadratic formula? Why is that more complicated? Well, right off the bat, what would happen is you would start with the quadratic equation here, multiply both sides by 4a. Now, that's not obvious. That's not an obvious move to make. Why not, I don't know, multiply by pi or something? And really, there's no particular reason. You'd have to remember that. You simply have to remember the key thing is multiply by 4a. And then you'd march up. If you were to remember that, that's great. You'd have this line. And then you could distribute the 4a. Okay, that's great. You'd have to remember that you'd want to subtract this 4ac, bring it to the right side. That's, again, is not obvious. And then on top of that, out of the blue, you'd want to remember to add b squared to both sides. Again, none of this is obvious. That's really a lot to try to remember. And then you could say, oh, I'm going to take the square root of both sides, and you have to factor all this. I mean, that's asking a lot. I think that is just too much. So much easier to do it, quote unquote, in reverse, which was start with the quadratic formula and basically go through the steps so that you end up with the quadratic equation. Now, I think that deserves a lot of extra credit. If you're willing to go through these steps, and for full extra credit, I'd want basically the steps that I have listed here. I'd want the steps to be like what would be necessary to convince other people in the class that you're right, that you're doing things properly. And that means not just put in 3 steps and hey, miracle happens and you all of a sudden got from one end to the other of this page. That's not going to cut it. And not even for mathematicians is that really sufficient. So if you do that, it seems to me that's worth 4 extra credit points on the exam too. And therefore, it will be 4 extra credit points on your final score. That's the way these tests work out. Each test is worth 25% of the final score. And since these tests are coming out to be 25 questions, 25 problems as kind of the baseline, each problem's worth 1% of your final grade. Well, if I have this extra credit added like I did the last exam, that could add up. That can have a great effect. So I'm saying this should be worth 4 extra credit points on the exam, and therefore 4% or 4 points on your final score. This is a big deal. Being able to do this, I think, is a substantial thing. It would require some practice. That's what I'd have to do. I'd have to go through this and just go through it a number of times to practice it. But what you're doing is you'd have to remember what the quadratic formula is, which you're going to have to anyway, and that I'll just leave it at that. You can ask if there's any question. I don't know if this is very hard to understand. I think it's pretty straightforward. But the way I have found here, and I just had to do some research, the way of doing it this way, of starting with the quadratic formula and then coming down to the quadratic equation, is by far the best, most efficient way. All right, so that's kind of the extra credit part that I've thought of so far. And thanks very much. I think this should complete everything required to do all the problems on 3.2 Pearson, which I believe is due this coming Sunday night. Yeah. Thanks a lot.